Hello, grade 11. Now we will start with a revision for the geometry. Let's talk about an isosceles and equilateral triangle. We talked about the isosceles. We said that the isosceles that has two legs from the vertex angle, as you see from here. Here we have this vertex angle. It has two legs, and these two legs are equal in the have an equal sides. That means they have the equal length. We name it with legs, and the sides that connect between these two legs, we called it a base. And we said that also that each leg, as you see from here, if we have this leg, the angle, that's we said it is an opposite to it. So the brown angle is an opposite as an angle for the side in a brown. And also, if we have this side, this will be its opposite angle. This is what we said about the isosceles triangle. We said the isosceles, it has two sides that they are equal with two angles are equal, and equilateral triangle, that's all the sides are equal and all the angles are equal. The first theorem here and the first one, if two sides of triangle are congruent, then the angles opposite those sides are congruent too. That's mean if I have here this triangle, he told me now, since these two sides are congruent, so for the first side, which I will color it with red now, it has this opposite angle. And the other side, which is in blue, it has this opposite angle. That means since the blue and the red legs are congruent.
Teacher, there's no sound.
How?
Teacher, are you talking?
Yes. Basmala, do you hear me?
Teacher, I can hear you.
Yes, teacher, I can.
Okay.
Teacher, me too can hear you.
Yeah, okay. So because of that now, the blue, and since now the blue and the red lines are congruent, so their opposite angles, the red and the blue, will be congruent too. This will be an isosceles triangle theorem. In the second theorem here, which is we called it a converse, that we said if two angles, I mean the red and the blue angles are congruent, if now these two angles, this one and this one, if these two angles are congruent, that's mean their opposite side will be congruent too. That's mean if the red and the blue angles are congruent, where's the opposite sides for the blue angle? It is this one. And the opposite side for the red angle, it will be the red line. So if the two angles are congruent, that's mean the two lines are congruent too. Now, in the theorem 4.5, told me that if a line bisects the vertex angle of an isosceles triangle, then the line is also perpendicular bisector of the base. What does it mean?
Teacher, I'm sorry I'm late, but the page wasn't appearing for me.
Okay. Now, here he told me that if you have I'm talking now about the isosceles triangle. If you have now an isosceles triangle, that's mean in the isosceles triangle, as I told you before, each two sides are equal. Now, if you have, and we said that at the beginning of the lesson, this angle, we called it a vertex angle. Now, if you have now a line segment, and this line segment, I bring it here. This line segment, it comes from the vertex of the angle. It comes from the vertex of the angle. So, if there's a line segment that comes from the vertex of in the angle of the isosceles triangle, so the two conditions here that I must have I must have isosceles triangle, and the point that the line segment start from it is a vertex angle. If it comes from the vertex angles and in an isosceles triangle, it's make two things. The first one, it cuts the line segment into two equal halves, and also it will be perpendicular on the base. So if a line bisects the vertex angle on an isosceles triangle, then the line is also perpendicular bisector of the base. It's perpendicular to the base and it bisects the base. It cuts the base into two equal halves. Now,
Miss, I have a question.
wait, Huda, please. I said after I finish the lesson, you can ask me. Now, if PQ is perpendicular to RQ, we have this triangle that we name it with PQR. If PQ is perpendicular to RQ, so what does it mean? That's mean if they are perpendicular, what does it mean? That's mean angle P is if PQ is congruent to QR. If these two sides are congruent, that means an angle P is congruent with an angle R. Is it right?
Yes, teacher.
Yes, teacher.
So this is which theorem? Is it theorem 4-3 or 4-4? If the two sides are congruent, so their angles will be congruent.
14.
It will be 4-3. Thank you. Now, look at number 6 here. In number 6, we have these two triangles. These triangles here, we have a bisector that comes from the vertex angle in the isosceles triangle, and it's cut their base into two equal halves and perpendicular, and it's perpendicular on the base. So underline the correct theorem number to complete the sentence. The theorem illustrated below is 4-3 or 4-4 or 4-5. Will be 4-5 because there's a line, it comes from the vertex angle, cut the base into two equal halves and perpendicular on it. Now, corollary to theorem 4-3, and we said that the corollary, it's a result to the theorem. What does it mean? That means if a triangle is equilateral, so the triangle and it will be equiangular. What does it mean? I told you that an equilateral triangle, that means all the sides are equal. So this angle, let's make. Now, for this side, the yellow sides, where is its opposite angle? It will be the yellow one. And for the orange side, this will be its opposite angle. And for the green side, this it will be its orange, the green, sorry, it's an opposite angle. In this theorem here, since now all the sides are equal, are congruent, and so all the angles will be congruent too. Why? Because all the sides are because since all the sides here are congruent, so their angles will be congruent. This is, we call it equilateral triangle. The second one here, that if the triangle has an equal angles, so it will be have an equal sides. It's as the same as these theorems. These theorems 4.3 and 4.4, I'm talking about isosceles triangle. If two sides are congruent, so the two angles will be congruent. Or if two angles are congruent, the two sides will be congruent. This is for an isosceles. For the equilateral, we have, it's like it, it's a result of it. We said in it here that if the triangle has, or if the sides of the triangle are equal, are congruent, so their angles will be congruent. And if the angles are congruent, so all the sides will be congruent too. Now, here, an isosceles triangle, it has two congruent sides. But the equilateral, it has three congruent sides. Now, the question here, the isosceles triangle theorem states that the angles opposite to the congruent sides are, who can tell me?
Congruent.
It will be congruent, yes.
Congruent.
So, in the isosceles triangle, that if the angles opposite to the congruent sides, it will be congruent. The sides and angles of which triangle are congruent?
Equilateral.
Equilateral. Thank you.
Equilateral.
I think I wrote something wrong here. Equal. So the sides and angles of an equilateral triangles are congruent. Now this is for this one, isosceles and equilateral triangle. Now, do you have any question?
Again, miss?
Yes. Hello, we said in the theorem that if there is a line that is cut in the it comes in from the vertex angle in the isosceles triangle, so it cut the base into two equal halves and it's perpendicular on it. And also, if there's a line, if there's a line comes in a triangle and perpendicular on the base and cut the two bases into two equal halves, so this triangle will be isosceles triangle.
Because the sides are congruent and this line came to cut it, so the base side will be also congruent and there will be two right angles.
Yes, it will be here two right angles. Also, since it is bisector, so it cuts the angles into two equal halves. Did you remember the definition of bisector sides? When I told you that the bisector, if it comes in angle, it makes the two angles equal, and if it cuts the sides, it makes them equal. So this bisector here, it may cut the angles into two equal angles, and it cut the base into two equal sides and perpendicular on the base, and it will happen in an isosceles triangle.
Okay.
Okay, now do you have any question?
Teacher, if you said to us that this angle, find the measurement. So and we know that the measurement of this angle in the isosceles, for example, each angle will have a measurement, but if we add all of the measurements, it will be 180. But
yes, it must be 180.
But in the equilateral, it must be equal.
Yes, it
All
must
the
be
angle.
equal. Yes, and every time it is 60. The angle of the equilateral triangle, it is 60. Because 180 divided by 3, since they are equal, it is 60.
Okay,
It is
because there
60.
was a question in the workbook. They're asking us to find the measurement, but it's not the first 60. We are making something.
Yeah, so here they are, all of them, they are 60.
Okay.
Okay, yeah, let's continue.
Miss, I have a question.
Yes, Huda.
Miss, the revision that you sent us in YouTube is the
Okay.
same one that you are showing us now?
No, there's another one. I continue here the revision of the 2 lessons in geometry and 2 in algebra. Yesterday I said first 4 lessons in geometry.
You will download this one in the YouTube?
Yes, inshallah, after I finish.
Teacher, I have a question.
Please, can you give me 1 minute? As I will write, I will come back. Now, let's talk about lesson 4.6. In the first 6 here, we have a new definition, which is hypotenuse. The hypotenuse, it is a side only on the right triangle. That's me. So it is only in the right triangle. There is no hypotenuse in the isosceles. There's no hypotenuse in the obtuse or acute triangle. Only in the right triangle. Now, the side that is opposite to the right angle, we called it hypotenuse.
Hypotenuse.
And the another one, we call them legs. And later on, inshallah, in grade 9, we will know that they are, we name it with adjacent and opposite. But now we will name it with legs. So the side that's opposite to a right angle, we called it hypotenuse. And this side and this side, we called it leg. So here we have one hypotenuse with 2 legs, and the hypotenuse is the longest side in the right triangle. As you see from here, this side, the red one, is it longer than any leg of the right triangle. Now, here, one side of a right triangle is or is not a hypotenuse. One side is what is only hypotenuse, and 2 sides are legs. A right triangle has 2 legs with 1 hypotenuse, and the length of the hypotenuse is always greater than the length of the legs, because I told you it is the longest side. Now, as you see in this picture, we have triangle ABC, GIH, and FED. Now, cross out the side that is not hypotenuse. Look at BC. Where's BC? This is BC. Sorry. In this BC here, is it a hypotenuse? Is it opposite to the right angle? No.
No.
Look at AB now. This is AB. Is it opposite to the right angle?
Yes.
Yes. So I say it is a hypotenuse. Now look at GH, this side here. Is it opposite to the right angle?
Yes.
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 And FD, is it opposite to the right angle? Yes. So I would say that HAB and GH and FD is what? Is a hypotenuse. Now, where's the legs? Look at AC. Is AC a leg?
Yes.
Yes.
AC is a leg. Now, what about AB?
No.
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 It's a hypotenuse.
No, not at AB here. No. HI?
Yes.
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 ED?
Yes.
Yes.
Thank you.
Teacher, not always the legs will be congruent to each other.
Sorry, not always.
Not the legs will be congruent to each other.
I have a conditions. And sometimes yes, sometimes not congruent. So we will say that these triangles are not congruent. Now, let's knock out. Now, as we said yesterday, we have 5 postulates or 3 postulates with 2 theorems that we used to prove that these 2 triangles are congruent. And these 5 can be used in right triangle, HL, SSS, SAS, AAS, or ASA. All of these 5 can be used in right triangle. So if you see any right triangle, it could be one from these 5, or 2, or 3, or all of them. But if you talk about any triangle but not right triangle, sorry, I will use the 4 theorems or postulates that I talked about yesterday, which are SSS, SAS, AAS, and ASA. All these 4 can be used in the triangles, which in any triangle, but not with a right triangle. Now the hypotenuse leg, or we called it H-leg theorem. If the hypotenuse and a leg of one right triangle, look at the first 2 lines here, it must be hypotenuse. Sorry, the hypotenuse and the leg in right triangle. So this theorem only can be used in right triangle if the hypotenuse are congruent and if the leg are congruent. So these 2 triangles are congruent. So in this triangle PQR and XYZ, if the triangle PQR and XYZ are right triangles and the first hypotenuse PR is congruent with the second hypotenuse XZ and the second leg PQ is congruent with the same leg in the triangle XY, so I will say now that these 2 triangles are congruent. To use the HL theorem, the triangles must meet 3 conditions. The first one, we must have 2 right triangles. The second one, the triangles have congruent hypotenuse. The third one, there's one pair of congruent legs. These 3 conditions, if you meet them in the right triangle, I can say that these 2 right triangles are congruent. Now, look at these questions here. For what values of x and y are the triangles congruent? By HL. Here now, he didn't ask me to prove that these triangles are congruent. He told me that they are congruent. So I have to go back. They are congruent. And we said in the first lesson that if 2 triangles are congruent, so all the sides and all the angles will be congruent and equal. Is it right?
Yes. Again, teacher.
Yes, teacher.
Okay.
Teacher, can you repeat again?
Okay. Now, we said that if I prove that I have these 2 triangles, and I told you that the first triangle are congruent with the second triangle. What does it mean? How can I take a benefit from this? That means this angle is congruent with this angle, and this angle is congruent with this angle, and this angle is congruent with this angle, and also this side will be congruent with this side will be congruent with the another side, and so on. And this the last side also. That means if 2 triangles are congruent, so all the angles and all the sides will be congruent. Is it clear now?
Yes.
Yes, teacher.
Here now we have the same, but I'm talking about right triangles. For this here now we have, as I told you, we have right triangles. In this right triangles, the first one, it was this one, and the second one, I have this right triangle. In the first one here, we have x plus 3, and in the second one here, we have x. Here we have 3y, and here we have y plus 1. Now, what did I told you? These two triangles are congruent. What does it mean? That's mean the hypotenuse are congruent and the legs will be congruent. Is it right? If I use
Yes,
the
teacher.
HL theorem. So HL theorem, that's mean the hypotenuse and one pair of legs are congruent. So the meaning or the definition of congruent, that's mean it has the same size. Congruent, it has same size with same shape. So that's mean x plus 3 is equal to what?
3y.
3y. Thank you. So x plus 3 is equal to 3y. The second one now. One pair of leg is congruent with the other one. That's mean also x is y plus 1. So here now, how many variables we have? We have two variables.
Oh.
And we have two equations. How can we find the value of x and y? Who can tell me?
Add the two x's and the two y's. It will be 2y and 2x.
Take the x alone and join the y's alone.
Yes. Find the y's alone.
Yes, thank you. So I can now use the first equation. In the first equation, we said x plus 3 equal 3y. This is an equation number 1, and this is an equation number 2. Now, in the first equation here, x plus 3 equal 3y. Can I substitute now x with y plus 1?
Yes.
So,
Yes.
I will bring now y plus 1 and I put it instead of x, because x plus 3 is equal 3y. Instead of x, I substitute it with y plus 1. Is it right?
Yes.
Yeah, then y plus 4 is equal to 3y. Then y is added to 4. Let's now, so the opposite of y of positive or added y is minus y minus y. So 2y is equal to 4. So what is the value of y? It is 2.
2.
Divide by 2, divide by 2. So I found now the value of y, which is equal to 2. Now, let's go back to the equation number 1. From equation number 1, we said that x plus 3 is equal to 3y. So let's now substitute y with 2.
Nice.
So it will be 3 times 2 equal x plus 3 minus 3 minus 3. So x, it will be 6 minus 3, which is 3. So the value of x is 3 and the value of y is 2. Is it clear?
Yes.
Yes, miss.
Teacher, where did the 2 go?
Sorry?
The 2.
Which two?
Here, x plus 3 equals 3
Why?
and 2. 2. Multiply by 2. So where did the 2 go after we finished?
Here it is 3 times 2, 6. 6 minus 3, it's a 3.
Oh, okay.
Now let's do number 13. In number 13 here, we have these two triangles and they are congruent, so we have the same idea. The first hypotenuse are congruent with the second hypotenuse. So 3y plus x is equal to y plus 5. Let's put y here, y here. So 2y plus x is equal to 5. This will be an equation number 1. The second equation, that y plus x is equal to x plus 5 plus x, or you can say plus x, yes. So y now, it will be,
Teacher, how you made it equal to each other?
because they are using the HL, it's the same idea. In 12, they are congruent, so the both of the hypotenuse will be equal and both of the legs will be equal.
Teacher, did we take problem 2 in lesson 4-6?
I forgot which is problem. Ask me on WhatsApp, please.
Okay.
So in this one here, I said that if the two hypotenuse are equal and the two legs are equal, so y now it will be 2x plus 5, and this will be equation number 2. And as I told you, 2y plus x equal 5, and y is equal to x plus 5. So let's now substitute instead of y with 2x plus 5. So 2, but instead of y here I have 2y plus x equal 5. Equation number 1, is it right? 2y plus x equal 5. This is an equation number 1. Now I will substitute now with y, but I have to put now 2x plus 5. Here, sorry. So I have to put now 2x plus 5. Then after that, two times 2 is 4x plus 4 plus x is equal to 5. So 4x plus x is equal to 5x equal minus 4. Minus 4, it will be 1. Here, like yesterday, like adding monomial, like what did we say yesterday? 4x plus x, I pick only 1x, and then I will add the coefficients, 4 plus 1, which is 5. Then, here after that, I have 5x before this step. 5x plus 4 equal 5. After I simplify it, minus 4, so 5x equal 1. So x, it will be 1 over 5. Is it right?
Teacher, how's adding polynomial any? It's like the idea. I added the x, 1x plus 4x.
Yes, it will be 5x. Is it right?
Yes.
Yes, I told you just pick one x